Welcome back to thinktankonlinelearning. This video I want to look on curve and potential of a vector field. So given that this vector field fz squared plus cos z plus 8xz minus y sin z plus 1 for the k component, and want to show that if f of xyz, you know this is the same for gradient, and we have a function here, and where this function is some scalar function, and part b want to find the function fxyz. I'm sure if this function satisfies this equation, you have to find the curve. It has to be conservative, so that means the k has to be 0. Okay, we're going to have the I component here, we're going to have the j component, we're going to have the k component. Okay, so now for the I component, let's write partial x for j component, partial y, partial z. Okay, now what do we have on the x component? We have 4z squared. For y component, we have cos z. For j, we have 8xz, sorry, that is the k component, minus y sin z plus 1. Okay, so what I'm going to do here, I'm going to first close the I row and the I column. So I'm going to multiply this diagonal together and subtract by this one. Okay, so I'm going to write here for I. So for I, what do we have? Okay, for I, we have partial y of 8xz minus y sin z plus 1. Okay, and I'm going to subtract by this diagonal partial z of cos z. If we define this with respect to y, that's going to become 0. This with respect to y, sin z is just a constant, so I'm going to be left with minus sin z. And for this one, we have a negative here, but if we differentiate cos z, we're going to have negative sin z, so we're going to have a plus sin z. Since negative and negative give us positive, and the answer is going to be equal to 0. Okay, now let's move on to the j component. So this one will be plus, and for the j component, we're going to have negative. So for the j component, closing the j column, which is this one, and we're going to close the j row. Okay, so we're going to look on this diagonal, okay, minus this diagonal. Okay, so we're going to have partial x of 8xz minus y sin z plus 1, okay, minus partial z of 4z squared. Okay, now let's calculate it. Okay, so if we divide this with respect to x, we're going to have 8z here, because z is just a constant, and 8. We're going to have 8z, 0 is 0, you don't have an x variable. For this one, with respect to z, we're going to drop the power, and we're going to have negative 8z, and this one will become 0. Okay, now let's go to the k. So we're going to have plus k, plus, negative, and plus. Okay, so k, what we're going to look on, I'm going to close the k, I'm going to close this k column and k row. So I'm going to multiply this diagonal, and I'm going to subtract by this diagonal. Okay, so we're going to have partial x, right, times cos z minus partial y 4z squared. And what we're going to have here, going to have 0, don't have any x variable. Here I'm going to have 0, and this one's going to be 0. So that means our k will be 0, 0, 0. That will give us simply 0. So if this k is conservative, that means it will satisfy this equation. Okay, so for part B, we're going to use the equation that we're given. Okay, so now let's equate these two together. For this one, we have 4z squared I plus cos z j and plus 8xz minus y sin z plus 1 for k. We're going to equate to this one. So this one is going to be partial x. Okay, partial x I of fx yz plus partial y for j of f x y z plus partial z, that is one is going to be equal to k of f x y z. Okay, so let's equate these equations together. Equating, so we're going to have 4z squared is equal for the component partial x. I'm not going to write, okay, let me just write it, fx yz, and what we're going to have, cos z is equal to partial y, that is the j component, of f x y z, and we're going to have 8xz minus y sine z plus 1 is equal to partial z f of xyz. Okay, since this question is going to include many equations, I'm going to name this question equation number 1, equation number 2, equation number 3. Okay, then out of these 3 equations, I'm going to choose what is this equation for me. So I'm going to choose equation 1. So here 4z squared is equals to partial x of f x y z. Okay, so what I'm going to do here, this one is a simple differential equation, so that is what the one I'm going to use. So I'm going to integrate both sides with respect to x. Okay, so if I integrate both sides with respect to x, what I'm going to have, I'm going to have 4z squared, and I'm going to put in x here, plus constant, this is going to be constant c, okay, and here I'm going to have f of x, y, z. Okay, so now let's take a closer look at the constant c. Okay, so here we have partial x. So that means we've differentiated this function with respect to x. That means we've cleared all y and z variables. So c is a function in form of, which includes y and z terms, right? Okay, so that means we can now write this one as f of z squared x plus the constant, which is h of y z, is equal to f of x y z. Okay, so let's call this equation 4. Okay, so now let's diff equation 4 with respect to y. Diff equation 4 with respect to y. Also, we're trying to connect these all equations together in order for us to come up with this function. Okay, so if we do this, what we're going to have, find this with respect to y. So this one is going to be 0. Okay, because we don't have any y variable here, we're going to have 0, and for this one we're going to have the derivative of this partial h of yz over partial y. Okay, actually there's a plus here, and for this one we're going to have partial y of f x y z. Okay, like this, and let's call this equation number 5. And now I'm going to equate equation number 5 with equation which have partial y, that is equation number 2. Okay, so I'm going to do it right here. So I'm going to have, for here, I'm going to have partial h partial y of yz is equal to, for this one, that is going to give us cos z, right? So you can see I've equated this. Okay, so now what I'm going to do, since this is a simple differential equation, again I'm going to integrate it, and in this case it's going to be with respect to y. So I'm going to have h yz is equal to the derivative of cos z, the integral of cos z with respect to y. It's going to be y cos z plus the constant here. Okay, we said the constant, when you differentiate this whole function with respect to x, it is yz terms. So in this case, this function only have y and z terms, so it's going to be g of z. Okay, that is going to be the constant. Okay, so now let's write equation number 4. You can now write it as 4z squared x plus, instead of writing this one, we're going to write y cos z plus g of z, and that is going to give us f of x y z. Okay, so now what we're going to do, let's connect partial z with this equation. So we're going to diff this equation, and you all know that this is equation number 4. We're going to diff equation number 4 with respect to z. Okay, so if we do that, what I'm going to have here, I'm going to have 8zx minus y sine z, okay, the derivative of course, plus g prime of 0 partial g partial z. G prime of z is going to give us partial z of f x y z. Okay, and now it's time we equate again. Okay, let's call this equation, since it's now a new equation, let's just call it equation Okay, equation number 7. So equate equation 7 to equation 3. Okay, so I'm going to write it here. Okay, let me choose red. So I'm going to have 8zx minus y sine z plus g prime of z is equal. So for the partial z, okay, look what I've written here. This is partial z, right? That's what. For partial z, what do we have here? We have 8xz minus y sine z plus 1. And if we equate, or if we solve for g of x, you can see this one is now equal to this one. So this should be equal, right? So this one is equal to this one, this one to this one, this one to this one. So I'm going to see that g prime of z should be equal to 1, right? Okay. And if g prime of z equals to 1, to solve for g prime of z, I'm going to simply integrate. So I'm going to have here partial of z, g of z is going to be equal to z. So now it's time to write our full scalar function. Out of space, I'm going to write this one. See, this is our function. So I'm going to have 4z squared x plus y cos z plus, for g of z, I'm going to have z here. It's going to be f x y z. Okay, so this one is our final answer. And the good thing is we can just prove to see if our answer is correct, right? And just prove. No? If we define this respective to x, we're going to have this one. This one respective to y. If we define this respective to y, we're going to have this one. Define this whole thing respective to z, we're going to have this one. So that means it's correct. Thank you for watching.